World Events, the Space Race. Welcome to History Explained, where we illuminate the past to better understand our present. I'm your guide to your daily journey through the past to empower the future. Today is Wednesday, July 16, 2025. As we do every Wednesday, we're exploring a major global event that shaped the course of world history. Today, we turn our attention to the space race, the intense competition between the United States and Soviet Union from 1957 to 1975 that transformed human understanding of our place in the universe while driving unprecedented technological innovation. This rivalry extended Cold War competition beyond Earth's atmosphere and fundamentally altered scientific research, education, and international relations. What makes the space race particularly significant is how it demonstrated humanity's capacity for extraordinary achievement when resources and determination are focused on ambitious goals. This competition not only advanced space exploration but also produced technologies that continue to benefit society while inspiring generations to pursue careers in science and engineering. So let's explore this remarkable period of human achievement, examining the political context that sparked the competition, the major milestones that defined the race, the technological innovations it produced, and its lasting impact on science, education, and international cooperation. The space race emerged from the geopolitical tensions of the Cold War, when the United States and Soviet Union competed for global influence through military, economic, and technological superiority. Both superpowers recognized that space capabilities would demonstrate scientific prowess while providing strategic military advantages. The competition's origins can be traced to German rocket technology developed during World War II. Both American and Soviet programs recruited German scientists, with Wernher von Braun leading American efforts while Sergei Korolev directed the secretive Soviet space program. The race officially began on October 4, 1957, when the Soviet Union launched Sputnik 1, the world's first artificial satellite. This basketball-sized sphere orbiting Earth every 96 minutes shocked the American public and government, who had assumed their technological superiority over the communist rival. Sputnik's success demonstrated Soviet capabilities in rocketry and electronics while suggesting potential military applications for intercontinental ballistic missiles. The satellite's radio signals, audible to amateur radio operators worldwide, provided undeniable proof of Soviet achievement and American vulnerability. American response was swift but initially unsuccessful. The Vanguard rocket exploded on the launch pad in December 1957, earning the nickname Sputnik in the press. However, Explorer 1 successfully launched on January 31, 1958, carrying scientific instruments that discovered the Van Allen radiation belts surrounding Earth. The Soviet Union maintained early dominance with a series of spectacular firsts. Luna 2 became the first human-made object to reach the Moon in 1959, while Luna 3 provided the first photographs of the Moon's far side, revealing terrain never before seen by human eyes. Perhaps the most dramatic Soviet achievement came on April 12, 1961, when cosmonaut Yuri Gagarin became the first human to orbit Earth. His 108-minute flight demonstrated that humans could survive in space while dealing a significant propaganda blow to American prestige. President John F. Kennedy responded to Gagarin's flight with one of the most audacious goals in human history. On May 25, 1961, he announced America's commitment to landing humans on the Moon and returning them safely to Earth before the decade's end, a goal that seemed almost impossible given existing technology. Kennedy's lunar landing goal required unprecedented mobilization of resources and talent. At its peak, the Apollo program employed over 400,000 people and consumed more than 4% of the federal budget, representing the largest peacetime technological undertaking in American history. Both space programs achieved remarkable milestones throughout the 1960s. Soviet cosmonaut Valentina Tereshkova became the first woman in space in 1963, while Alexei Leonov conducted the first spacewalk in 1965. These achievements demonstrated expanding human capabilities in the space environment. American achievements gradually closed the gap with Soviet accomplishments. The Gemini program developed crucial techniques for orbital rendezvous and docking while proving that astronauts could survive extended periods in space, skills essential for lunar missions. The race intensified with both nations pursuing lunar landing capabilities. The Soviet Luna program achieved several firsts, including the first soft landing on the Moon and the first lunar samples returned to Earth by robotic spacecraft, maintaining pressure on American efforts. However, the Apollo program's methodical approach began paying dividends. Apollo 8's lunar orbit mission in December 1968 provided humanity's first close-up views of the Moon while producing the iconic Earthrise photograph that transformed environmental consciousness. The climax came on July 20, 1969, when Apollo 11 astronauts Neil Armstrong and Buzz Aldrin became the first humans to land on the Moon. Armstrong's words, "That's one small step for man, one giant leap for mankind," were heard by an estimated 650 million people worldwide. The Moon landing represented America's most visible Cold War victory, demonstrating technological superiority while fulfilling Kennedy's seemingly impossible goal. The achievement showcased democratic society's capacity for extraordinary accomplishment through voluntary cooperation and scientific excellence. Soviet response to the American lunar success was complicated by the death of chief designer Sergei Korolev in 1966 and ongoing technical problems with their lunar rocket. Unable to match the Apollo achievement, they shifted focus to space stations and long-duration flight. The Soviet Salyut program pioneered space station technology, demonstrating that humans could live and work in space for extended periods. These achievements laid foundations for later international cooperation in space while advancing understanding of space medicine and psychology. Competition gradually gave way to cooperation as both nations recognized space exploration's potential for peaceful collaboration. The Apollo-Soyuz test project in 1975 saw American and Soviet spacecraft dock in orbit, symbolically ending the space race while beginning a new era of international cooperation. The space race's technological legacy transformed numerous fields beyond aerospace. Miniaturized electronics, advanced materials, computer systems, and manufacturing techniques developed for space applications found widespread civilian uses, creating entire new industries. Medical technologies advanced significantly through space research, including improved monitoring systems, artificial limbs, and water purification methods. The challenges of keeping astronauts healthy in space led to innovations that benefit patients on Earth. Communications were revolutionized by satellite technology pioneered during the space race. Weather forecasting, television broadcasting, telephone communications, and internet connectivity all depend on satellites that trace their origins to this period of intense innovation. Educational impact was equally profound, as space achievements inspired millions of students to pursue careers in science, technology, engineering, and mathematics. The Sputnik moment led to massive investments in education and research that transformed American universities and schools. The space race also changed humanity's perspective on Earth itself. Photographs of our planet from space revealed its beauty, fragility, and isolation in the cosmic void, contributing to environmental awareness and the modern ecology movement. International cooperation in space gradually replaced superpower competition. The International Space Station, involving multiple nations working together, represents the space race's most positive legacy while demonstrating how former adversaries can collaborate on ambitious projects. The economic impact extended far beyond government spending, as space technologies created new markets and industries. GPS navigation, satellite communications, and remote sensing capabilities generate billions in economic activity while improving life quality worldwide. Space exploration continued advancing after the formal space race ended, with robotic missions exploring every planet in the solar system while space telescopes revealed the universe's vast scale and complexity. These achievements build on foundations laid during the competitive era. Private companies now play increasingly important roles in space exploration, developing new technologies and reducing costs while maintaining the innovative spirit that characterized the space race. Commercial spaceflight promises to make space accessible to far more people. The space race's lessons remain relevant for contemporary challenges requiring international cooperation and technological innovation. Climate change, pandemic response, and sustainable development could benefit from the same focused effort and resource mobilization that characterized this remarkable period. Modern space exploration emphasizes international cooperation over competition, though new players like China and India are creating fresh dynamics in space development. The cooperative model established after the space race provides frameworks for managing these new relationships. The space race also demonstrated how competition can drive innovation while ultimately leading to cooperation. The same nations that competed fiercely for space supremacy eventually found ways to work together on projects benefiting all humanity. Environmental monitoring from space now provides crucial data for understanding climate change and managing natural resources. These applications fulfill early visions of space technology serving peaceful purposes while addressing global challenges. The cultural impact persists through science fiction, educational programs, and popular fascination with space exploration. The space race created lasting interest in science and technology while inspiring artistic and cultural works that continue influencing popular imagination. The space race stands as one of humanity's greatest achievements, demonstrating our capacity for extraordinary accomplishment when ambition meets determination and resources. While born from Cold War competition, it ultimately transcended national rivalries to inspire global cooperation and scientific advancement. The period reminds us that seemingly impossible goals can be achieved through sustained effort, international collaboration, and commitment to scientific excellence. The technologies and knowledge gained continue benefiting humanity while pointing toward even greater achievements in space exploration. Thank you for joining us for this exploration of the space race. Tomorrow, we'll be back with our Cultural Insights episode examining the Olympic Games and their role in promoting international understanding and athletic excellence throughout history. If you enjoyed this journey through history, please like this video, subscribe to our channel, and hit the notification bell. What aspects of the space race do you find most inspiring or relevant to contemporary scientific and technological challenges? Let us know in the comments below. Until next time, I'm your guide for History Explained, where we believe that understanding yesterday is the key to navigating tomorrow.